Okay, so as I said, a little bit more complex, not so much that's crazy, but a little bit more. Okay, so we have 1 plus secant x sine x tangent x. So I'm going to first change this. Secant is 1 over cosine x times sine x over 1 times, and then I'm going to change tangent. Again, first strategy, change everything to sine and cosine. So that is sine x over cosine x. So if we look at this, we can see that we can actually do 1 plus 1 times sine x is sine squared x over cosine x times 1 times cosine x is cosine squared x. So sine squared x over cosine squared x is going to be 1 plus tangent squared x. So if you remember, our second method is look for Pythagorean identities. It's a little small, but if you look right here, we have tangent squared theta plus 1 equals secant squared theta. I have 1 plus tangent squared theta, but with addition it doesn't matter. So this is the same thing as tangent squared x plus 1, which means this is going to equal secant squared x, which is what it will simplify to. So those Pythagorean identities come in pretty handy, especially when we have a sine squared, cosine squared, secant, tangent, cotangent, anything we have a squared in ones, we're going to look at those Pythagorean identities. Okay, one of our strategies also talked about if you have two binomials to multiply them. So our next one is going to be sine theta plus 1 times sine theta minus 1. Anytime I have binomials like this, we're going to start by foiling or multiplying them out. So that's sine squared theta minus sine theta plus sine theta minus 1. Okay, if you notice I did theta instead of x, same thing, it doesn't matter, x, theta, it's just a variable. So our middle terms are going to cancel out. I have sine squared theta minus 1. Ooh, the squared and the 1 makes me want to look at my Pythagorean identities. But if you notice, I don't have any minus 1. But could I change some of this around to get this to work? Oh, what if I subtracted this 1 and moved the cosine over? So my identity reads sine squared theta plus cosine squared theta equals 1. Let's rearrange this. Let's minus the 1 and minus the cosine squared theta. So I have sine squared theta minus 1 equals negative cosine squared theta. Well, now these match. So I know it's going to be negative cosine squared theta as my answer. Okay? So this one simplifies down. It's negative, but it's still simplified down. Let's do one more where we multiply it out. So again, if you don't have that paper printed out, you will want it printed out. It comes in so handy. Okay, we're going to do 1 plus tangent x times 1 minus tangent x. We're going to FOIL this, so we'd have 1, that's a 1, minus tangent x plus tangent x minus tangent squared x. So, looking at this, these are going to simplify out and I'd get 1 minus tangent squared x. Well, that makes me want to look at my identities. And looking at my identities, so if you have it, I have a tangent squared x plus 1. I cannot think of any way to get that, so it's 1 minus tangent squared x. I could change it to sine and cosine, but that's not going to simplify out. So in this case, this is actually simplified right here. I cannot go any further. they're not always going to simplify down to a nice single sine, cosine, or tangent. Sometimes the simplification is just down to a smaller expression than the original. Okay, I've got 2 more on the next video for you, so hold on.